We're going to start with chapter 7. Its first section is going to be called Multiplication Properties of Exponents. Okay, this is what been working with the juniors this pretty much whole quarter so far. Started doing it with my lower junior class. Now we get started with you guys. We're going to take this fairly slow, okay? A couple of key terms up top. Monomial being the first one, all right? A monomial. It's a number, a variable, or the product of a number and one or more variables with non-negative integer exponents. Okay, so a monomial is considered either a number, a variable, or the product. Product means what? Multiplication. Product of a number and one or more variables with non-negative. So if something's non-negative, that means what? It's positive. Integers are what? Uh-oh. Way back one, what are your integer numbers? Whole numbers, positives, negatives, okay, but for this, they can't be negative. Okay, so non-negative, so positive integer exponents. Basically, you can't have negative exponents. They can't be fractions. Okay? Everybody good? All right. An expression that involves division by a variable. Division by a variable. Not just division, but if you have division by a variable, it's not a monomial. Okay? If you have a constant, keyword for a constant, monomial, that's a real number. Okay? Constant is just a fancy way to say number. All right? So we have, it looks like 8 expressions down there to determine whether each expression is a monomial or not. I'm basically just going to go through and talk about each one, cross out the ones that aren't. Okay? Circle the ones that are. So 10. 10 is just a number. It's a constant, so is it a monomial? Yes. Okay, f plus 24, yes or no? Yes. Dylan says no, why not? It's adding. Okay, no addition, just multiplication. Okay, has to be multiplication and that's it. Multiplication, division, but no division by variables. All right. H squared, yep. J, yep. Negative x plus 5, no. Okay. Does anybody know what f plus 24 and negative x plus 5 would be called? No? Binomial. Very good. Okay, binomials. There's 2 of them. We're going to get to that but later. 23, a, b, c, d squared. Yes or no? Yes. Okay, even though you have a constant with multiple variables happening, it's all still multiplication. So you're good. Second to last, xyz squared divided by 2.
No. Oh, yes. Yes. Hold on. No, it's not. It's not. No.
Federico's got the nod, the bobblehead nod going.
No. My God, no.
Dylan says no.
I said no.
Isaiah says no.
No.
Look up top. An expression that involves division by a variable is not a monomial. What's 2? 2 is a... No. 2 is a constant. So you can't divide by a variable. It doesn't say anything about not dividing by a constant.
Oh.
Nope. Monomial. So, NP divided by N.
No.
No. Okay. So you're going to have to know, because a lot of these rules we're going to learn today and the next lesson all have to do with these being monomials. All right, that's what this chapter is going to be about, is everything's monomials. All right? Questions on that? Okay, 3 to the 4th, you have 3 as the base, you have 4 as the exponent. And what it tells you to do is to take the base and times it by itself the exponent number of times, right? 3 times 3 times 3 times 3. Okay, makes sense? Okay, going into detail. We've done, like, you guys, like 3 squared, you know, you just did 3 times 3 is 9, boom, done like that. Okay, no big deal. Now we're going to start getting a little more complicated, and now we're going to move into eventually where they're not numbers. Okay, we're going to do variables. So now we can't just do, okay, well, what's 3 times 3? Oh, it's 9, that's easy. Now we have to actually derive a rule to figure out these questions. Okay, just general cases. So, we have these two next. All right. Same logic. 2 squared is just 2 times 2. 2 to the 4th is 2 times 2 times 2 times 2. How many 2's you got total? 6. Okay, just like how that pre-worksheet or pre-chapter stuff you did, when you had them all listed out like that, you wrote it as an exponent. Okay, that's exactly what that means. Same way, you can take it and spread it all out. Now, anybody see a shortcut? Mr. Watson, you just add the exponents together. Okay, notice the same base. That's the key, though. All right, same base. So the bases of 2, add the exponents together. Okay, everybody good. And then I think 2 to the 6 is 64, but that's not the point. Okay. So down below, if you would rewrite those, that would be what? 4 to the 5th. Okay. I'm going to give you the same answers. Okay, as if you took, 4 times 4 times 4 times 4 times 4 by hand. If you did 4 to the 5th in your calculator. Either way, same thing. So now that we know that, we can write a rule, which is what this is called. Okay, the first one is called your product of powers. If you write nothing, make sure you at least write that part. Here, let me use a bolder color to make sure you get it. There it is. Woo! Okay, in words, it means to multiply 2 powers that have the same base. You add up the exponents, okay? They've been numbers. They're about to change to variables. But you still just add the exponents together. Okay? There's 2 examples down below if you look at it. You got b to the 3rd times b to the 5th equals b to the 3 plus 5 right here, which is just b to the 8th. Same with your g. G to the 4th times g to the 6th equals g to the 4 plus 6, which is g to the 10th. Your first power rule, the product of powers. We're eventually going to learn 7 of these. 7 exponent rules, basically. Okay. This is the first one, this is the basic one. Okay, so we're going to go into questions that start using these rules now. Okay, now one of the hardest things about multiplying monomials, dividing monomials, anything to do with what we're going to start here in chapter 7 is having 2 sides of your brain. Okay? Side 1 is all these new rules, all these new fancy dangled rules with your exponents and your bases, and when do I multiply, and when do I add, and when do I subtract, and yada, yada, yada. The other one is the calmer half of your brain, where you do what you have always done. And it's important to make sure that you keep both of those in sync with one another. And don't let one dominate the other. Okay? Point being, this is multiplication when 2 parentheses touch, yes? What's 6 times 2? 12. Okay? It's 12. So you just do that. It's 12. Just like normal. Just like you've always done. Don't let the whole, I got to add these together. Don't put 8. Okay? Maybe you're thinking, no kidding. I've seen it. Okay? I've seen it. All right. Now, you have n to the 3rd and n to the 7th, so you do what with those exponents? You add them. So n to the 3 plus 7, which simplifies to 12n to the 10th. Okay, so for this one we have 3p t to the third times the expression p cubed t to the fourth. So I always still do, no matter what, my numbers first. So I'm going to do 3 times what? 1, because there's a 1 hidden right there, right? Okay, so 3 times 1 gives me 3. Great. Now what? What's my p's? Mr. Watson.
P to the fourth.
Why to the fourth?
Because there's a 1.
Because there's a 1 here. Okay? Remember, if it's there, it's hidden. So there's a p to the first right here. So p to the first times p to the third. You do 3 plus 1 to give you p to the fourth. Okay? You take each variable individually when you have more than 1. Okay? Now you got t to the third times t to the fourth, which becomes what? T to the seventh. And that's it. Whenever you have a base that's to a power, you multiply it by itself how many times? To the exponent times, right? Okay? Here's where our mindset switches. Instead of considering 3 the base to 2, consider 3 squared as the base to the exponent of 4. So then I'm going to take 3 squared and write it out how many times? 4 times. 3 squared times 3 squared. And now we have the same base being multiplied together. What do you do with those exponents? Right there.
Add them together.
You add them. So what's 2 plus 2 plus 2 plus 2?
8.
8. So the answer is 3 to the 8th. Okay? Shortcut is what? Multiply your exponents together. Okay? This is the funky one. This is called power of a power. Okay? Power of power, right? Here is your rule for it, okay? When you have the power of a power, you multiply the exponents. This is the weird looking one. Okay, everything else we do is going to be somewhat calm. This one's odd. It looks different. It looks strange. You have a base to an exponent to an exponent. Okay, so I'm going to teach you guys a new word today. It's called to the. Okay, it's redneck. It's a noun. All right, it's called to the. It's a thing. It's when you take an exponent to an exponent and Mr. Mormon is telling you how to do it. That's the definition. Look it up. Okay? To the. T-O-T-H-E. No hyphen. For example, B to the third to the fifth. Okay, when you say it like that, you're looking for to the. When you hear to the, you multiply. Alright? So B to the third to the fifth, 3 times 5, or B to the 15th. Alright, right there. Okay. Same way with G. G to the 6th to the 7th, 6 times 7, 42. Power of a power. Okay, so we have 2 to the 3rd to the 2nd to the 4th, which becomes what? 2 to the 24th. Dalton, how'd you do that so fast? Is? Good. You can multiply all these powers together. Okay, it doesn't matter how big it gets. So 2 to the 24th power. Okay? To be quite honest, for this, I really don't care what 2 to the 24th actually is. Okay? I want to know if you know how to add those all up. Okay, now this one I'm going to work out. Alright, so we have 2yz squared to the third. Okay, so consider 2yz squared as your base. And we're going to multiply that by itself how many times? 3. Okay? Sub 2 yz squared 2 yz squared 2 yz squared. Okay? It turns it into a question like we had earlier. Okay? But now you have 3 terms instead of just 2, which is no big deal. So you still go through, multiply your numbers. So 2 times 2 times 2 gives you what? 8. Y times y times y. Add up those exponents, you get y to the y to the third, right? 1 plus 1 plus 1. Okay? Z squared times z squared times z squared. Z to the 6. Okay? Makes sense? Shortcut? Anybody see it? Dylan.
Multiply the 3 by the exponents of y and z. Distribute.
No.
Because you can't.
It's not technically. Okay? Okay, I like the y, I like the z. You cube them. What about the 2 though? What do we do to the 2?
Multiply it by.
Oh, I think you just almost said what I wanted you to say, and I was going to call you out on it. Burlesman, what do we do to the 2?
Multiply 3 as an exponent.
Made it the exponent of 3. We cubed it. All right? Now, remember what I said about your 2 sides of your brain. They got to work together, not against each other. We cubed the y, right? Everybody sees that. Y cubed. You cube z squared. Z squared times z squared times z squared. You get z to the 6. Everybody good? The most common mistake I see is instead of seeing 8 here, I see 6. Anybody know why? Because they just do 2 times 3.
Yeah.
Okay? You have to keep the numbers separate from the variables. Okay? 2 is still your constant. You are cubing it. The rule goes like this. You cube everything. It's a product up top here. Okay, yeah, I switched it a little bit from what's posted up, but that's okay. Okay? Whenever you have a product, which means a multiplication, and it's to a power, you take everything inside of it to that power. Okay, right here. The example shows us kind of like this. So negative 2 xy cubed all to the 5th. You take negative cubed to the 5th, or negative 2 to the 5th, sorry. X to the 5th, y to the 15th. And then the coefficient, the constant in front, you actually take to that power. Okay? Not multiply. That's like the biggest mistake maker that I see. Alright? Down below are 3, right? Yeah, 3. Make sure you write those 3 down. Okay? These 3 bullets, write these down. Alright? This is what I look at. Okay? Because that's all the rules we're going to learn today. So the next couple examples, we're going to combine them all into one. And then do them all together, okay? I look for these 3 bullets. Okay, because basically these problems are 3 points. Did you meet all 3 bullets? I took off a point for each one you did. To be considered simplified, and that's what the directions are going to say now, is simplify. You need to make sure that each variable base appears once. Not twice, not 3 times, once. And that's the main one. Okay, for now, that is the main one. The other 2, make sure there's no power of powers. And the third one, all fractions are simplified, as always. Here's one. We got 3x y to the 4th all squared, negative 2y squared cubed. Okay, first thing I always do is I look and take care of my big exponents. All right, when I mean by big exponents, I mean my exponents that are going to affect the most. Okay? This y has an exponent of 4 on it. Okay? That's not a big exponent, though, because that just affects this y. This square exponent, though, that affects all of this. This 2 and this 3, that affects all of this. So those are my bigger exponents. Okay, so I take care of them first. First one I look at is this right here. What can I rewrite there? Make it negative 2y to the 6th. Okay, so keeping this step by step. Take a negative 2y all to the 6th power. Okay. Now, there is somewhat of an order of operations in here. Okay? We have 2 operations today, basically. Exponents and multiply. What goes first between those 2? Exponents. So you always take care of your exponents first for that reason. All right? So, individually, let's do this monomial first. So square 3xy to the 4th. So 3 squared gives you 9. X to the 2nd gives you x squared. And then y to the 4th times y to the 4th gives you y to the 8. Power. Multiply there, okay? You only square your numbers themselves. Okay? All right, everybody take out your calculators now, because this one might be a little big, and I want to make a point. Okay. I want everybody right now to do negative 2 to the 6th power in your calculator. Minor, what'd you get? Who agrees? Negative 64. Wow. Not a lot. Anybody got something different? Isaiah?
64.
Ooh, Isaiah says 64. Federico's with him, 64. Melinda, 64. Anybody with negative? Anybody on team negative 64? Besides Mr. Jansen with minor? That's it? The end?
Well, that's just what I got.
That is what your calculator says. You're right. And you're going with it. I like that. Stick with your guns. I like it. But you know what?
You're wrong.
The calculator is stupid. The calculator can only do what you tell it to do. All right? Now, here's what I want to do. Yeah, I know. Go away, truck payment notification. Negative 2 to the 6th means you do negative 2 times 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 negative 2. How many times do we multiply into negative? 6. Which is what type of number? Even. And when you multiply a negative even number of times, the result is positive. So why is minor getting a negative 64?
That's her calculator, stupid.
Melinda.
She multiplied negative 2 more.
No, I think she probably put it in. She probably did the notation wrong. Okay? When you take a negative number to an exponent, this is the notation you got to use. Okay? Is that what you did? You didn't put it in parentheses, right? Yeah. If you take a negative number to an exponent, you got to put it in parentheses. Otherwise, it follows order ops. Your calculator is stupid. It only does what it tells you to do. Okay? If you don't put it in parentheses, what it's going to do is that exponent first on just the number. That's it. Not the number and the sign. Okay? 2 to the 6 is 64, and then it takes the negative of it. The opposite of it. Okay? Makes sense? So you get 64 y to the 6th. Okay? Help me out here with 64 times 9. $576. X to the second. Y is going to be to what power now? Y to the 14th. That's where you add them up. Okay. Rewrite those two powers as what? Negative 4b to the fourth. Good. Okay. That's what I always do first. If I have a power of a power on two big exponents like that, I do that first. Okay. You can technically, you can square this and then square it again. I don't do that. I just multiply these, do the fourth, and then do it to the power one time. Okay. Make sense? Are we good? Yeah? No? Talk to me, people? Yeah? Okay. All right. Now, everything in here gets what? Starts with the C. Cubed. Cubed. Okay. The 3 to the third is cubed, to the second is squared. Okay. Good. All right. So we cube everything. So we cube A to the second. We cube B to the second, which is going to become what? A to the 6th and B to the 6th. All right. The question is, what's 1/2 cubed? What's 1/2 cubed?
1/2 and then you do like 1/2 and then put it in parentheses for
You can, but doing it in your head it's a lot easier. What's 1/2 cubed? Do I like decimals? Get out of here. Mr. Watson. 1/8. 1/2 times 1/2 times 1/2. How do you multiply fractions? You multiply the numerators and multiply the denominators. So 1 times 1 times 1 gives you 1. 2 times 2 times 2 gives you 8. 1/8. Okay? A lot easier than worrying about the notation you got to put it in your calculator with. 1/8. A to the 6th. B to the 6th. Times. Okay, we're going to get B to the 4th there. Well, first off, negative 4 to the 4th power is going to result in what type of number? Positive or negative? Positive. Okay. So then what's 4 to the 4th? I was thinking 256, right? Because 4 cubed is 64. And 4 to the 4th should be 256. Okay, so you get there. Okay, let's pick it up just a little bit. What's 256 times 1/8? Yeah. First assignment, Humbert, in the timeline. Okay. Rosen?
32.
Should be 32, right? 256 divided by 8, essentially. Okay, A to the 6th, and B to the 10th. Okay. Okay, we got about 4 minutes left. I'm going to give you your homework, and then I'm going to talk to you guys for just a minute, okay? So your homework's going to be page 394, 1 through 20, which is essentially 2 through 20 because it's 1 through 20 even. Okay, so 2 through 20 even. All right, not a lot of problems, but still, okay?